Okay. All right, here we go. 5, 4, 3, 2. Hi, everybody. Thanks so much for joining us for the 2024 Mentee Showcase. I know that's confusing, but this is for projects that happened in 2024. We had a huge amount of students this year, something I'm really proud of. We had 29 students in the year 2024, which is awesome, an increase from I think we had 15 the year before that. And this coming program, we're going to have even more because we have 9 mentorships posted, which is the most that we've ever had. So make sure you take a look at those. Applications for spring are open now through February 9th. So if you're looking to participate in the 2024 mentorship program, you can apply for that now. Again, at the very end of this session, I'll go over questions and answers to answer your questions live about the mentorship program or the mentorships that are coming up. But first, I'll introduce myself. My name is Megan Lane. I'm the community director here at RISC-V International. I've been with RISC-V for 5 years, which this is my 4th mentee showcase, which was fun to review my notes from the last ones and just all the things that have changed. So I focus on community and educational initiatives. My real goal is to help grow the student community and ensure that we have educated individuals that are prepared to take over these thousands and thousands of jobs that are on the market now and coming. So while I say on the market, one of the links that I threw in the chat is about our jobs board. This is where you can find all of the mentorships that are currently published. So check that out, as well as where many of our members publish their open RISC-V positions. So just mark that page and look back there because we get a lot of new jobs posted. A couple of the other things I put in were the github.com/RISC-V/learn. This was actually created as part of a mentorship. And what this is a resource that shows beginner and intermediate courses and books and resources that the community thinks are the best for you to be reviewing. So I think that, oops, sorry, Camille, I somehow just unpinned that. It's not letting me see anything else. So that's just something to consider, is that there's lots of positions out there. And so just keep looking at those pages. Look at the educational resources. They do change. We've also got the GitHub first good issues. So that is something that is being added to. But one of the biggest questions I'm asked is, how do I contribute to RISC-V? And that's where you can start, right? Because I think a lot of it is overwhelming. In order to be really involved, you need to be a member. And membership is free for either your university or for yourself as an individual. So once you join, then you can get into all of the different task groups, and you can learn more. I recommend you join the meetings and especially the groups where you're most interested to figure out what it is they're doing. It'll take a few meetings for you to just sit in and listen and figure out where they're at and how you can contribute. But the more you ask people, how can I contribute, the better off you're going to be, because you go in well prepared, you do small tasks, which gets you more embedded into each tooling, and then you really are able to contribute on a wider scale. So like I said, the mentorships are published now. You will find them on our jobs board, and then when you click into each of those, it'll take you to the LFX platform, which is where you apply. And you may have some questions about that, which I can answer later. But really, I just want to thank you for joining the 4th Mentee Showcase. I always really appreciate the individuals that participate in this, the speakers and the mentors. It's just a really great opportunity for people to give back, right? The mentor is giving back in training to the mentees, and the mentee is giving back to the community. We select projects that support the broader ecosystem, and all the projects that are submitted are from RISC-V member organizations. So we get a lot of great projects. We can't take them all, but the ones that you see are the ones that we felt would be most helpful for the community. And thank you for attending and showing interest in RISC-V. We hope you find these talks informational and helpful. And if you're not a part of the Slack group already, I recommend you join the Slack channel. I'll grab that in a little bit and throw it in here. But that's a good spot to go in and ask questions about the mentorship program and your application. Oftentimes, other students will respond to you on the answer because they've been in there for a while, which I really appreciate. And, I just think that this is such a great opportunity, and we're really happy that you're all here. So without further ado, I will go ahead and start the talks. And again, remember, we really recommend that you ask questions or chat with each other while this is going on, because it's the best way for you all to get to know each other, for you to find other people you might be able to work on projects with. So just keep that in mind. And one more thing I will tell you before I start the talks is that we do have a virtual showcase coming up. And we're pretty excited about this. It's going to be a global, so you can do it from anywhere, your home, your university, anywhere you want, online hackathon. So if you're not a part of the educational newsletter, we'll throw that link in there. Those are the first people that we tell about everything, including mentorships, launching, sponsorships, scholarships, are all go in there. So if you're interested in online hackathon, make sure to sign up for the newsletter to find out about that. And thanks for being here.
Hi, my name is Linda, and today I'll be talking about my efforts towards sailing downstream, one goal at a time. So a little about me. I'm a software developer with a keen interest in backend systems, and I'm also excited by frontier research and technology. I was a summer 2024 mentee for the Sailing Downstream 2 project. A little background on our project. The sail in Sailing Downstream refers to a language that's used to describe processor architectures, which includes widely adopted ones like ARM and, of course, RISC-V. The RISC-V cell specification is quite robust and has been adopted by the RISC-V Foundation. So although it's robust, the RISC-V cells model use of the relatively unknown sail and also a single or camel parser complicates its usability. So now the overarching goal of Sailing Downstream is to enhance the RISC-V cell model as the single source of truth. And we'll do this by developing a backend to extract key details and reformat them into JSON, which is a more widely used format, of course. So one of the ways we are going to get here and one of the goals of Sailing Downstream is to enhance the RISC-V cell specification. The RISC-V cell model currently includes a lot of important information like encode, decode, extensions, and a whole lot more, but it does lack in some crucial information like instruction names, description, formats, and pseudo instruction, etc. So my contributions towards this specific goal was by adding names to the instructions. So for each instructions, I'd reference the RISC-V manuals to get the name. And now for the simple instructions, which now are the instructions that are not grouped, for example, the jump and link instruction below, I'd add the name to the union clause ST. And for the grouped instructions like the U-type mnemonic, I will add the names to each relationship of the mapping. So my mentor and I opened a pull request, and we were able to successfully upstream the annotations for the base instructions to sail. So that was quite a win for us. So Another one of my contributions toward this goal was by proposing support for pseudo instruction. SAIL currently does not support pseudo instructions, so my mentor and I worked towards getting a format, and we borrowed from the existing structure of the instructions. So this proposed format evolved to a separate pseudotype after having a conversation with the SAIL community, which essentially separates pseudo instructions from executable instructions. The conversation on pseudo instructions and how to support them and if to support them in SAIL is still ongoing, and you can follow the conversation on GitHub. Goal 2 of sailing downstream towards the single source of truth is to improve the cell parser, our cell parser that outputs JSON. So the cell language, as I've said, is written in OCaml. Quite a powerful language. I actually learned it during the mentorship program. However, a lot of people do not know how to write in OCaml, which can pose as a barrier. So to address this, the JSON backend was developed to extract information from the RISC-V cell specification and reformat it into JSON. In the first iteration of Sailing Downstream project, there was a working version of the backend which was implemented. And now the goal for Sailing Downstream 2 was to streamline certain aspects and to resolve existing issues. My contribution towards this goal was first to fix the order of operands in the JSON output. The operand order in the JSON output was incorrect because we were extracting the operands from the function clause execute, which didn't align with the actual assembly syntax and how it's represented in the RISC-V manuals. So to do this, I updated the operand extraction process to pull operands from the mapping clause assembly instead, which now aligned with the assembly syntax represented in the RISC-V manuals. So here's an example of how an instruction looked before and the new version. So the operand order is as per the RISC-V manuals. Another contribution I made toward this goal was by fixing missing or incorrect JSON output. One of the fixes was missing names and descriptions in the JSON output, specifically for instructions that had fewer than 2 inputs. So the solution to this was to adjust the parsing logic. And as you can see between the old and the new JSON output for the e-break instruction, you can see in the old version the name was not present, and in the new version the name was present. Another fix was for the syntax in the JSON output. Optional operands were displayed in line, which made it ambiguous and also a little bit confusing, as you can see in the example. So now the solution was to enclose optional operands in square brackets. So by a glance, you can tell what is and what isn't an optional operand. And the third goal for Sailing Downstream was to showcase the JSON backend capabilities. So as part of the Sailing Downstream project, an interactive RISC-V ISA website was created to showcase the capabilities of the JSON. And now in Sailing Downstream 2, the focus was now to make the website more user-friendly and to address a few bugs. Now, my contribution towards this was to add dark mode support. I implemented dark mode functionality, as you can see, to allow users to switch between light and dark modes. I do actually encourage you guys to check out our website. I've linked it here. I've also linked other resources that I utilized in the making of this presentation. I am very grateful for your time and for your attention. Bye.
My name is Vedant Tiwari. So I was part of the LFX mentorship program in the summer of 2024, where I primarily worked with the SAIL programming language and sort of developing an instruction translation between the SAIL programming language and QMU code. I was part of the Sailing Downstream 2 project, which essentially the goal was to create a JSON representation or a web page or maintaining a web page which showcased the various different instructions in the RVI64, RVI32 format, their respective sale code, and also the descriptions to make it easier for people to refer to view, as opposed to reading through the available manuals. So first of all, what is sale? So sale is basically a high level language that is used for describing the instruction set architecture. It basically follows semantics, a formal semantics. And in addition, it also provides capabilities such as type checking, emulation, theorem proving, test coverage, and memory models. This is basically the layout of the SAIL programming language. It provides um, the intermediate representation, the different capabilities of the language itself, and also the AST conversions of the definitions itself as well. So essentially, why are we interested in QEMU? First of all, what is QEMU? It is an open source emulator and virtualizer. It provides an entire full system simulation and also provides capabilities such as API virtualization, hypervisor integration, and various forms of translation. Um, so the motivation of this project was to basically bridge the gap between the different specifications provided by the SAIL programming language, and also the formalisms provided by the QEMU emulator code. Um, the SAIL programming language is more traditional and formal in sense, and QEMU has more practical implementation. So we just wanted to provide a translation mapping between both of them. In addition, we also wanted to integrate QEMU into RISC-V support. We wanted to help QEMU developers refer back to the QEMU code that is responsible for the translation mechanisms to make it easier for them to refer to make changes to the QEMU code itself, because it has been maintained and created for a very long period of time now. And in order to go back and make changes, it's very labor intensive and can lead to inconsistencies and a lot of errors. In addition, we also want to allow for collaboration across downstream projects. We want to make it more extensible and also want to create a larger community for both SAIL and QMU development. In addition, the goals of the project was we wanted to provide mapping between the various downstream projects from SAIL, and we also wanted to create a standardization. So how did we accomplish that? Basically, we identified key files for translation in both SAIL and QMU, which is our test downstream project. We also developed various translation templates. Then we understood the different pattern matching clauses that we could take into account for parsing in the SAIL code. Then we refined it, and then we built a JSON for type database. And the next goal is to create an actual web page where we can view these instruction translations. So you take the SAIL code in this specific file over here. Um, let's say, and this is like the one function clause. Now, this is a way of declaring functions in SAIL. It's very similar to OCaml. So you essentially have these match statements which contain these cases, which represent um, what should be the value of any of these registers, or generally for these constants if these cases were matched. And then in this case, what should be the value of the different registers? For example, the RD register over here. So, and this is the now say you actually have match statements that describe the type, what we should focus on for that specific instruction. But in QMU, we essentially have um, an entire function that represents the instruction and what should happen inside of it. So the next steps would be to identify the different keywords for the template itself, and also for parsing the various different important lines of code in both the SAIL and QMU that we require when we parse them to create our generic template. Um, we treat it as form of parsing text. So we take different parts of code and then we form the template. So this is another set of characteristics that we take into account. So for QMU, we take into account the helper function that is declared in a separate file that is called, that takes into account the context, the register, and the immediate. Similarly, we take into account the mnemonics that are, we take into account the words, um, or the characters that create the mnemonics, and then the standard templates. And then we translate the sale code as well. We take this part of the sale code because that's what's important to us. And then we create a generic template, and then we translate it into a table. So in the sale code, if we go back, we found this line to be important because that contains the register and the value that it should have. And then in the QMB code, the only primary line that we actually take into account is a genset function that takes the context, the register, and the immediate value that should be assigned. And these are the field names for the for consistent convention. So some comments that we had while working through this process was that for specific instruction types, we have to take into account that specific lines, such as for LUI, uh, the LUI mnemonic is important, or the mapping clause assembly is important. And then this line over here tells us that what is the decoding format for the instruction and whether it's been sign extended or not. Uh, in addition, this is the very elementary essence of the sale function, and this tells us what is the immediate value that we need to store in the RD register. Um, so moving on to the actual output. So this is what the actual output looks like when we run our generic C file, which takes into account, like we take the entire QMU code and the sale code, the files responsible for both, and we run a script that's able to take into account all these characteristics and the different keywords that we use when we parse both of these files to create um, this mapping where we have the mnemonic name and then the QMU code and then the sale code that's responsible for both of for essentially for this mnemonic or this instruction name. So this is just like a initial patch. It's not exactly what we envisioned in the previous slides, but it's something that we were able to come up with in the due time. So the next goal is to sort of refine this further and send a patch to the QMU team and sort of get their feedback on this. That's pretty much all from my side. Thank you so much. If you have any comments or feedbacks, do let me know. Thank you.
Good morning, good afternoon, and good evening to one and all present here. This is Jay, and today I'm feeling very honored to present and deliver what I have done in my last 3 months of mentorship program. Undoubtedly, I have had an incredible opportunity to work and dive deeper into the open source hardware and to contribute to RISC-V and open standard instruction set architecture. This journey has not only enhanced my learning towards RISC-V, but also allowed me to collaborate with the amazing community that is RISC-V shaping the future of open source hardware. So I'm really very excited to walk you through the works that I have done and what are the impacts it has on the RISC-V opcode repository. For this, I would like to talk about initially what is a RISC-V opcode and what the repository contains and how it is well maintained now and what the repo is all about. Moving towards the three pillars of my scope of work, that is refactorization, optimization, and maintainability, in order to have better performance in terms of various aspects like maintainability, scalability, readability, and to be of properly well documented repository. I would also like to talk about the methodologies and approaches that I have used to achieve what I have discussed now, various optimization and modularization, so that the solution would be more efficient and easy to read. Lastly, I would like to extend my work that is not only the contribution, but also it extended up to collaboration in reviewing and fixing other contributors' PR. To put in a nutshell, RISC-V opcodes are the basic units and the fundamental building blocks of the RISC-V ISA architecture. They define the operation that a processor can perform from basic arithmetics to the complex tasks. So the RISC-V opcode repository, the GitHub repository, serves as a central source for maintaining the opcode definition, ensuring the clarity and consistency between various of its uh, definitions and interpretations. It includes metadata like encodings, bit fields, argument mapping to facilitate easier integration into simulators, compilers, and processors. It also plays a very crucial role by enabling developers to have accurate and consistent interpretation and implementation of the RISC-V ISA architecture. Moving on to the RISC-V ISA, due to its extensible and very much comfortable uh, interpretations, it is ideal for various applications and diverse domain like embedded system to high performance computing. It supports various extensions like RV32i, RV64M, and various advanced functionalities. So in general, the opcode defines and dictates the processor how a binary instruction should be interpreted uh, to perform tasks such as data movement, computational flow, and control flow, and other tasks. The repository in this for this process to be perfectly streamlined, it offers a well structured. So as we discussed just now, how RISC-V opcode repository offers the process to be smoothly streamlined. So it is very important for us to know why RISC-V is so important. So, as we all know that the RISC-V opcode repository serves as a centralized source for maintaining the opcode definition. So it ensures that the definitions are consistent and their interpretations are being cleared among all the various implementation process. It fosters the customization as we discussed about its extensible nature, making it very ideal for the diverse applications from embedded system, high performance computing, and much more. So by offering all these features, it actually accelerates the development time to have the developer verified opcode definition, which is readily available on the uh, opcode repository and which will save their time in the development process. So the RISC-V opcode repository, of course, because of its open source nature, and the RISC-V GitHub repository proves as a central resource for the RISC-V community, and people are more than welcome to contribute to and collaborate. People coming with their issues and their issues fixed and their issues are properly addressed onto this repository, making it as a knowledge sharing to further enhance the ecosystem. So the current status of the RISC-V opcode repository has a parsing logic which contains various dedicated scripts for conversion into several formats such as C, Scala, LaTeX, Rust, Verilog, and various file format, which will enable the developers to incorporate those files to have their integration and implementation to their own purposes. So while we talk about the contents of the RISC-V opcode repository, I already discussed about like it contains various metadata like bit fields, encodings, and argument mapping. So it enumerates the standard RISC-V instruction opcodes containing the control and status registers as well. So the artifact generation is nothing but the passing logic which already the repository contains. So it will generate the artifacts, the files, that is the files like .c, .latex, .verilog. So the artifacts would be generated from these scripts and can be used purposefully for other various tasks to be performed. Moving on to the methodologies that I have used to fulfill my scope of work, which I have shown in the very first slide of the introductory slide. So the two main methodologies that I have used here is the optimization and the modularization one. So while modularizing the codes, the purpose is to reuse the already written functions and the function to be in the format of to perform single task at a time. And while optimization will focus on reducing the number of lines of code for easier maintenance and easier to scale and readable. So using these three things, I was able to write the dedicated scripts to generate specific artifacts like C, Rust, Go, as Verilogs, and various other file formats. In this way, we are able to achieve a maintainable code and that can be read, re, that can be easily read by various other developers and programmers, and will also open the door for new contributors who are very new to the RISC-V world. At the end, we also focused on that the repository should be well descripted, like every function to be properly commented with their proper parameters, input parameters, and what would be the output of those functions which we have written. In this slide, I would like to talk about the various engineering principles that I have used for the above methodologies that we have discussed just now. So the very first thing is to focus upon the optimization techniques. How could we better write 1,000 number of lines of codes to reduce it to in 100 lines of codes? So for this purpose, I have used various comprehension Python libraries, which could be used for list comprehension, loop comprehension, and dictionary comprehension, which will result into a concise method, and consequently, it will reduce the number of lines of codes. Moving on to the modularization of the codes, that is a very lengthy function performing 2 or 3 functions could be modularized into a smaller chunk of methods, which will only focus on a particular task based on a given parameter. In this way, we could be able to break down a very lengthy and complex code into a smaller, understandable codes, which will also help us to reuse the methods, and it could be a centralized method that could be used in various other purposes. We used the basic principles of software engineering and the object-oriented programming like encapsulation and abstraction and the intermodule communication. This helped us to write properly modulated code. Moving on to the dedicated script, it will focus on the language-specific parsing scripts like converting into C, converting into Rust, converting into Verilog. A unique universal file could be translated into their own dedicated scripts. So the dedicated scripts will be using a common interface called parse.py, which will call the specific artifact generated function, which will result into the corresponding artifact like C, Rust, Go, and various other. So they will be all sharing a common interface parse.py file, and then they can be easily use the shared utility functions among them. So at the end, they will have the overall cohesion needed to perform their tasks smoothly. So by using all these principles, we would be able to write a proper readable code, because the readability and maintainability of the code is required to scale the repository and even the project so that it could be maintained for a longer run, and it could be sustained for a long-term purposes. So for readability, I used the single responsibility principle for a function, that a particular function will focus on only one task to be performed, and the function to be properly described using the arguments and the return parameters, and properly documented what this function will use the method to perform a particular task. So by having a compact and modular structure of the function will ease your maintainability, and it will have a significant impact on your scores of scalability and maintainability. The well-documented function will also help to easily understand the function, and it will also reduce the redundancy. So, with all the methodologies and approach that we have used to refactor and optimize our parsec logic, and indirectly we are able to achieve the significant number of lines of code reduction and a very good number in the maintainability improvement and the readability enhancement. So here the numbers present like the previous LOCs were like 1,259 lines of codes, and on the reduction, we have just saved the 1,172 lines of codes and to only keep 87 lines of code. In this way, the parsing logic only contain the abstracted 87 lines of code, which will move further into their own dedicated scripts. This lines of code reduction enhance the code quality, as well as they have a better visualization in terms of cleaner codes with properly and well maintained documentation in terms of comments, in terms of parameter and return parameters and input parameters, and the argument that has been passed to a function. So overall, it helps us to maintain a perfect lines of codes, and I think these 87 lines of codes are much more maintainable than 1,259 lines of codes. So based on these lines of codes, we have around a 90% of estimated maintainability enhancement, because upon the reduced LOCs, it helps us to directly translate into the improved maintainability, thereby reducing the technical debt and maintaining a long-term scalability and the long-term sustainability of the opcode repository. In this way, we are also able to lower down the burden of maintenance overheads, and there are aspects that I'm going to discuss this later, which I have used to have the easier updates to the repository in terms of CI/CD pipelines that I have speed up to them, and there are many more such things. Based upon the reduced LOCs, we can estimate around 85% of readability improvement. That is, with shorter codes, they will imply modular function, which we have, of course, like there is a very long method which we have shortened into several smaller methods, which could be easily understandable. For the smaller and modular methods, the developer can find easy to debug the codes, and which has more complex, which made them a very less complex code, and it will clear the they will have a clear visualization of the structure, what is being done into the function, and what could be expected from a function to be done while giving the specific representation. So overall, we have touched all the different aspects of a software project that could have like significant reduction in the LOCs, have a proper maintainability percentage, and have 85% of readability improvement. So while I move further towards the shared utilities, how this repository and the parsing logic actually worked. Like I have a centralized Py functions, Py script that is called a parser script, like I have already shown you as a parser.py, which will have a respective artifact generation scripts. Like they have only 2-3 lines of code, and it will call the C script to convert a particular general format into a C file format, or into a SVerilog format, or into a Ghost script, and much more. So while this parser will call the artifact generated methods, they will have a specific scripts like c.py. So in the c.py, they will call the shared utility function, and this shared utility function will have a common function which could be reused upon various dedicated scripts. The shared script in turns have multiple dependent functions which could be reused as in, like, let's suppose a function 1 is there. The output of the function 1 will go into the input as in function 2, and so on. So they have a shared dependency and a shared cohesion between each other. So at the end, we could be able to generate the artifact using a make file, which is used for generating various artifacts, and which could be verified also based on our needs. Moving on to one of the tasks given to me was to have, like, we have already have codes written for the artifact generation like Rust, Go, C, LaTeX, SVerilog, etc. So there is a missing output generated file which is commonly used in today's world, like RISC doc. So I followed the same methodology and same principle. I just add a parameter called -RISC doc parameter, which a parser file which call this parameter to call the ASCII doc util script. So this ASCII doc util script will call related shared utility function, which we have discussed are the common function which are shared between different generated, uh, which are reused between which are used interchangeably between different scripts. So at the end, we have commands like ASCII.pdf generator, which will help you to generate a PDF, like here as an example being shown, RISC-V encoding details, and we can easily also generate a web page as an HTML page, so that it could be easier to visualize as on a web page and also on a PDF format. So moving on to the collaboration step, the thing is, I came to contribute to the RISC-V opcode repository, but in turn, I also have hands extended towards the collaboration in terms of suggesting the best approach in fixing some of the PRs done by other contributors, and also to review them and to put my forth the points which could be helpful for them also to learn, and for me also to enhance my skills. So in this way, I have had a collaborated environment while I was working with the RISC-V opcode repository. So this is kind of an extended work, which I found myself that the speed in the CI pipeline was taking a very longer time because of the Python version which we have supported, the later versions we have supported, like Python 3.9 to 3.13, which are the late. The Python version lives was about like 5 to 10 years approx. So we have supported the repository to run the CI also on the latest Python version. So this also led to increase the time of the pipeline that is taking to complete its task. So what I have used the cache-based approach and avoided the redundant install commands. This helped me to to already use the install version uh, instead of using using the install commands again and again whenever a PR is being merged or a PR is being generated. So after the CI pipeline is being modified, the current time taken is like 3 minutes to 15 seconds. So we we have achieved overall of 2 minutes of speed up from the previously written pipeline flows. So in this way, the pipeline is got enhanced and we have saved a lot of time in running the test cases. And this pipeline has two major functionalities, like it will test all the test cases that we have written. And the second thing, uh, it will verify whether the changes made in the PR haven't impacted on the artifacts so generated, which could be the main functionality of the repository. So at the end, I would also like to mention some of the accomplishment which I received from the Andrew Waterman, which is also the chief engineer of the RISC-V, and thanks to the Raphael, which also helped me to get introduced to him. So he was mentioning about my work and what I have done so far, and I'm really very much eager and excited to extend my hands more onto the repository and to contribute more so as to have extend the RISC-V opcode repository to a next level. By continuing my work, I was on the top list of contributors. Here we could be able to see this. Despite of having some of the fewer commits from other members, but still my name is in the top because of the impactful PRs that I have contributed to this repository. And I'm very grateful to the opportunity that I got to work with this RISC-V opcode. I would like to thank all of the RISC-V community which made this program possible, and thanks to Megan, which is, who is responsible for end-to-end communication, whether it's a mentorship, whether it's a mentor to mentee guidelines and the flow and the all the process that is being here, that is being included in the RISC-V mentorship program. So it has been a wonderful and astonishing 3 month experience for me. Raphael, of course, Raphael is my mentor who is have a weekly updates from time to time and also helped me to learn other aspects of the RISC-V based on the RISC-V Learn repository. And with the time being, me and my mentor also shared about what else is going in the RISC-V community. Like he also talked about the high performance community, which is currently Raphael working on it. And he also shared some of the slides that he used to give it to the Brazil government. And I'm very thankful to the Andrew who reviewed my PR and also take me forward one step ahead of reviewing a PR and also allowed me to have my hands to address the issues, to fix the PRs, and much more. So it's being a very wonderful journey for me, and I would like to thank all of the RISC-V, the whole RISC-V community who are here also to listen to the presentation. So, Andrew, Raphael, Megan, you guys are amazing, and I'm really very finding myself very grateful to have this opportunity in my bucket. And I'm feeling such a satisfied now that yes, I can also go into the realm of RISC-V and VLSI. So I like to thank all of them who are present currently to listen to my presentation and all of them who got their time from their busy schedule to listen to me. And like I'm very much thankful to all of them which helped me to have this presentation and have my mentorship program to be successfully conducted. Thank you. Thanks a lot.
Awesome. I love hearing from the mentees about their experience. I think it's really unique, this opportunity, and I actually had the opportunity to reach out to everyone who's been a mentee in the past, and it was just so cool to see where they are now and how this experience really benefited them in the long run. So that's why I'm so passionate about this. I had an internship when I was a lot younger through a similar program like this, and it's just made me really passionate about this program. So thank you so much to the mentees and the mentors. I mean, the mentors put a lot of effort into this as well, and they're not getting paid. They're just, supporting the ecosystem and supporting the next generation of RISC-V engineers, which is what I think is what I think this is all about, right? So thank you to everybody for participating and listening. And now I'll open it up to live Q&A. If you have questions about the mentorships, let me put the link in there again for you. Why does the Linux Foundation give only one mentorship per person? Is that the question, Amit? So each mentorship receives, it's a budget, like at least from the RISC-V International standpoint, we give the first person selected the stipend. And so one person does get paid, but what we noticed is that the experience is honestly what it's all about. And so that's why we have extended it to, if the mentor themselves feel comfortable having multiple mentees, then we allow them to. I think last semester we had one project that had 4 mentees. So again, the first one, the one that they felt was the most qualified, receives the stipend, and the other 3 in that case are able to participate in the same exact way. The only difference is that they don't receive the stipend. And we do it that way in order to offer a lot more individuals. I'm not sure. Oh, so the Linux, I am sure that that's the same as what I'm saying. It's budget, right? Like we can only pay for so many projects, and I am not associated with the Linux kernel bug fixing one, but I know that they wanted to open that up to as many people as possible. So it's an opportunity. Honestly, I think that everyone should see this as experience. Having these, okay, having these experiences on your resume is really what this is about, because people aren't coming to me and saying the stipend did this to me. They're saying having the Linux Foundation and RISC-V International mentorship is what got me into the PhD program at the school, is what got me into my next internship at Meta, is what got me into working at Apple. That's what I'm hearing from the mentees. So I really hope people see this as experience to contribute to the open ISA, and in other cases to open source, right? It's just a great opportunity to have on your resume. Okay. Is there a way to extend the mentorship to an internship or master's thesis? So it depends on the project. I do know that one of the people that was a mentee last year is being hired on right now in that company. So it is totally possible for it to go to a higher level. We don't guarantee that, because it just depends on if there's an opening in that organization. In regard to a master's thesis, I think you need to talk to the mentor specifically. So if you were hired, you could go into it saying, I'm really excited about this. I not only want to do the 3 months, after the 3 months, then can I take this into my master's thesis? So that's something you would want to talk directly with each mentor. Is it open? So is the program limited to students only, or is it open to the people that are already professional like myself? So you can be a professional. The biggest problem is if you're already working 40 hours a week, this program is 30 hours a week. And so I just don't know how that would work out. Paul put a good link in there, and I'll put this link in as well. So this shows the eligibility rules. And this will answer the last question that just came in. So that's the eligibility rules. Essentially, it's, that you're 18. One rule that I should let you know is that you cannot have been an active participant in the program previously. So we only allow you to have one LFX mentorship with any project within the Linux Foundation. And that's because we want to give as many people these opportunities as possible. You can only apply to 3 in one term. You have to be eligible to work in your country. So there's some countries where it's prohibited for you to work based on US federal law. So you would have to know if your country was in that. You're applying on your own behalf. Yeah. So those are essentially the main rules. Can you provide? Okay, let me make sure I'm not missing anybody. Students. So Marco, you can apply if they do go with people who have the best experience. So if you are experienced in that level and you're prepared to work your full-time job and this, it's something that each mentor takes into consideration. I hope if that doesn't answer your question, feel free to write more. Okay. Is there a prerequisite to the program? That's the link I just sent and discussed. Can you provide a person to talk about creating a manufacturing customer RISC-V in Australia? I can't answer G05's question. I'm not sure. If you want to send an email to learn@risc5.org and further detail what you're asking for, I can see if I can find someone to connect you with. Okay, I'm just curious about contributing during this period. I'm particularly interested in RISC-V as a first-class citizen in kernel CI, and I saw that the repo link is a link to Linux kernel. For contributing, should I focus on the contributing to the kernel or the repo link you sent? Oh, sorry, things are popping up and I lost your question. I'm not sure in that case. I would contribute wherever you're able. I think that shows, as you're saying, that you are really committed to this and you're interested to it. So I wouldn't say one is better than the other. I would say the GitHub link that is connected in the repo, that is the one that the mentor provided. So that's obviously the one that they're paying the most attention to. That would be my assumption in that case. So I think contributing in advance is a fantastic way to stand out, right? What you're really looking to is to stand out because a lot of these mentorships have like 300 people that apply. Are the 30 hours per week indicative considering the task or they are hard minimum? It really depends on you and the mentor. Honestly, I know that some students work more than the amount, but there may also be times where you don't have time to put in the 30 hours. No one's tracking your hours. Really, we can tell how much work you're doing based on your contribution. So really, on your end, the goal should just be to get everything done that you can to really show your best foot forward. Can mentors be individual contributors or self-employed folks, or should mentors be gainfully employed? So this is a member opportunity. So only member organizations can provide a mentorship opportunity. Should you wish to partner with a member organization? I've seen people do that in the past. So that's an opportunity, Paul, but it is a member benefit that we provide to the RISC-V International members. Are RISC-V internships available on the mentorship page or is it separate? So if you, well, no, I'm worried maybe it's not on there. Hang on. So if you go to the job board, let me double check on the mentorship page. So when you're on the mentorship page, there's a big yellow button at the top that says apply now. If you click on that, then it will take you directly to the to the job board on RISC-V International, which lists all the different mentorships. That link I just put in, you can also get the link to the Slack channel on there. It also, towards the bottom, another one of the questions I get asked is about stipends. The stipend link is in there as well. So I would suggest checking out that page because that's got most of your information that you need on it. But yeah, so they're available on, so essentially what happens is you can go from the mentorship page to the jobs board to then the LFX mentorship page, which is where actual applications happen. And so the application process, you essentially pick the project. Like I said, you can only do 3. You pick the projects that you want to participate in, you click apply. And then once you click apply, then you'll see in your tasks section where you go to put in your resume and your cover letter and your coding challenge. I should say that if you don't fill out all 3 of those, not all of them require a coding challenge. I think there's just 2 that don't. But if you don't fill out all 3, your application is not looked at. You need to submit each 3. And one of the things I can tell you is don't chat GPT your cover letter. Or if you do, edit it heavily, because I have read so many of them and they all start exactly the same. Where you found out about the mentorship, and what we want to know is, what are your skill sets that really make you eligible for this? What is it that you're doing now that we can build on by having you in this mentorship? So those are things to think about in doing that. And I'm gonna see if I was just pretend applying to one. So let me see if I've got it up still. I don't. But once you go through the process and you select the 3 you want to apply for, then you'll see a task section within LFX, and that's where you upload those 3 things. But if you have any questions about the process, or in some cases the mentors themselves are in the Slack channel. Oh wait, let me see here. Let's see. I think I can share my screen with you and show you a little bit more. So once you go from the jobs board, this is where it'll take you, and you can see the mentorships that we have open at RISC-V International, as well as what other projects have open. And so once you click the apply button, you fill out basic details, and then it'll take you to your tasks list. So that's sort of what the front end of that looks like. So just something to consider. Are there any other questions I can answer while we're here? Or if not, I'm in the Slack channel, and either myself or a mentor, or in some cases, other individuals will answer questions for you. Cool. Awesome. Well, we're excited to see your applications. I think it's it's a great opportunity. As you can see, these mentees are really grateful for the opportunity, and I recommend that you apply for ones that you're not only excited about, but that you're qualified for. And I know that is one of the biggest questions, is how do I become qualified? I do recommend that you check out the RISC-V Fundamentals course, because that'll go over the basics. I'm trying to find that link for you right now. The basics. Oh, there she is. Of RISC-V and sort of the ISA in general. So I recommend that. We have a lot of free courses. Even if you don't get into one of the mentorships now, there's a lot of opportunities that you can participate in to still participate. Oh, will you grab that link from Paul, Camille? What is the timeline? So you need to apply by February 9th. So you must submit your application with all of your completed tasks on that Sunday. I close the projects on Monday, and we start to review as a group. So the timeline, let me grab that really quick. 1 sec. So we then give the mentors about a week from there to review all of the applications. So they have a week to review the applications. The week after that, they start to schedule interviews. And then the week after that, and then at the end of that week, they need to let me know who they usually do their top 5 candidates, in case someone was selected for another project or can no longer participate. They select their top 5. And then that's when my team reaches out and makes sure that you are interested. And then we send you contract paperwork, and you start March 1st. Let me quadruple check that that's correct. I believe the program runs, March 1st to May 31st. I'm not sure about that, the ideal writer verification mentorship. I would check within the program. Again, like when you go through the process, it says if there are skills that you need. So check in each of those, and see if you have the skills that are needed. If you can read through and understand what the process is, if you can complete the coding challenge without a problem, then that's the best way to do it. Can you please provide the other timelines, months this mentorship is active other than spring? So then there's spring. Summer runs from, hang on, let me look in the back end. They changed the website. Okay. Summer runs from, thank you, June to September. That sounds right. Yeah, June to September. And then I believe the last one is, no, I think it might June, August, September, June, July, August. So it's June, July, August for summer. And then September, October, November is for the fall quarter. So I think that those are the different timelines. I don't have all the timelines set on, it'll be, the month before it'll be 2 months before the mentorship that the applications open. And then a month before is when, the deadline hits, and then we give mentors about 2 to 3 weeks to then decide on the mentee once applications have closed. So again, summer is June, July, August, and then fall is September, October, November. Thanks, Jay. Yeah, I agree with that. I think like the money is really not what this is about. It's really about the experience, and what it's really about is having the name on your resume, because that's what makes you stand out, right? Is your resume. Yeah, no, I definitely think that this is a great place to start. Again, like the feedback that I'm getting from the past mentees and where they are now in their careers is so cool. And they do attribute it. Like I don't say it myself. They told me that this mentorship is what they get asked about in interviews, is what people reach out to them about. So, oh, you're welcome. Yeah, I'm really excited about these opportunities. I think it's a great experience. And what is open source and an open ISA, but making contributions that you're not getting paid for. That's really what the community is about, is building something bigger so that the ecosystem can continue to grow. And maybe in a couple of years, some of these people are going to be coming out with their own businesses, which I just can't wait to watch. So any other questions? Love that. Would love that. Just one more thing to note is that we do have the, I'm going to stop the recording for this.